Dear students, today we discuss the unit number 3, 3D modeling. These are the topics to be covered from the unit 3, conversion of views 2D to 3D, 3D to 2D, parametric and non-parametric modeling, three features of 3D modeling and disadvantages, surface modeling, BAW body in white, solid modeling, Boolean operations like unit subtraction and intersection, etc. So conversion of views, uh, 2D to 3D, creating a 3D object from the 2D orthographic views. These are the three important things we are followed. The given 2D orthographic views, front view, top view, side view. They understand the features based on the identity shapes, heights, cutouts, holes, and their position. Results 3D isometric views. This is the 3D object formed the given 2D views. Step-by-step conversion process we have followed. The one is start with base plate for top view, add the side step, remote portion as seen in the side view, add the upper platform as per front view, add the cylindrical pose on the platform, create through the cylindrical hole. So important tips we have followed. Always starts from the top or front view. Observe hidden line carefully, match dimensions and alignment, visualize shapes in the layer bottom of the top to bottom. So 2D view shows length, width and height in separate views. Combinations of all the informations correctively gives the actual 3D shapes. Convert 3D to 2D in CAD system. Based on the system, 6 steps follow. Start with 3D model, select standard view, orient the model, generate 2D views, uh, add hidden lines, dimension and annotate. From this three diagram are clearly showed 3D isometric model, orthographic projection line by using first angle method, 2D orthographic view. So for the reference plane, we have to using top XY, that is horizontal plane, front XZ, that is vertical plane, right YZ, that is vertical plane. The projection method we are followed first angle projection. The object is placed in the first quadrant. The views are projected into the plane. From the 2D orthographic views, top view by the plane and the elevation and right side views. So symbols and notations are used like visible line, interline, central line, dimension and a section line. So the benefits are followed by the CAD system. So precise manufacturing information, standard communication in engineering, easy to understand the object, help in inspection and quality control. So these are the benefits here followed by the CAD system. For also using by the third angle projection for the reference based on the component. Non-parametric model. Non-parametric model, a direct history for free modeling. So three features of 3D modeling based on the extrude, cut, fillet, chamfer, hole, shell and pattern. So non-parametric modeling workflow: create basic shape, directly edit your geometry, add, remove features, finalize the model. Changes are made by the directly dragging, pushing, pulling faces, edges are vertically without going back to the history. Example: base solid, add boss and cut bracket and cut packet and add hole in the fillet. So in this non-parametric modeling is the 3D modeling approach where the geometry is created and edited without using parameters, dimensions or features history. So advantages of the non-parametric modeling: fast and flexible. So quick to create and modify the geometry without worrying about history. Easy to use, simple workflow, idea for beginners and quick concept modeling. No failure due to the history, no features dependency error or broken reference. Ideal for complex shapes, easier to create organic shapes and interact geometry. Works well in the imported data, easily edit and repair imported models, that is STL and step. Time saving, reduce time in design changes and prototype development. So for the application: concept design, made and die design, reverse engineering, product development, medical dental. These are the applications we are followed to using by the non-parametric modeling concepts. Then surface modeling, So creating 3D models using only for surface, so no solid interior. The surface modeling means is the 3D modeling technique that creates the shape of an object using surfaces only without any thickness or solid volume. Surface encloses a space to form the shape. Types of surfaces: plane surface, then cylindrical, sphere, cone, torus, and a numerous surface, ruled surface, and trimmed surface. For the types of surface, common surface operation based on extruded surface, revolved surface, sweep surface, loft surface, boundary surface, trim surface. Workflow of the surface modeling: create the basic features, edit, refine, and then join surface, check the continuity. Then fifth one is thickness. The example of the car body surface modeling: reference the sketch of the curve, create the main surface, main and trim, main and trim surfaces, join surfaces. Thickness from it is an optional method. So checking the surface quality, go GO, that is the position, then edges meet but may have a gap. G1 tangent, edges are tangent, smooth direction. G2 curvature, curvature is also continuous, very smooth. Advantages: ideal for complex and organic shape, requires less system sources than solid modeling, easy to modify, the flexible during easily design, used for styling, aesthetics, and ergonomics. Limitation: no volume of mass properties, not suitable for engineering analysis directly, difficult to maintain without proper surface maintenance. So this is the surface modeling creating for the 3D models. So next one, wireframe geometry. So basic elements: point or line, arc, circles, splines, then polygon and a polyline. So example of the wireframe models: so cube, pyramid, cylinder, cone, sphere, and then complex shapes. That is a wireframe model for the example. Common wireframe operations: create, modify, transform, edit, measure. Uses and application: conceptual design, 3D reference construction, architectural structure, mechanical design, CAM and CNC operations. So the advantages: simple and fast to create, uses very little system resources, easy to modify and edit, provides clear structures and reference for complex models, foundations for creating surfaces and solids, helps in the design, intent and accurate layout. And surfacing methods: based on the surface creations method, advanced surface methods, and surface editing methods, then combined surfaces. Then sixth one is surface quality, surface quality analysis, workflow from surface to solid, then application and advantages of surfacing. So in this basic surface creation, so plane, extrude surface, revolved surface, sweep surface, then loft surface, boundary surface, steel surfaces, bad surfaces, blunt surfaces, extend surfaces for advanced surface creation, and then trim surfaces, split surfaces, off surfaces, fillet surfaces, unit trim surfaces for this surface editing method, combined surfaces, join, knit and stitch, thickness also for the combined surfaces based on the diagrams are clearly shown. So workflow from the surfaces to solid, create this structure, knit surfaces, check and close the gaps, thickness, application, automotive body design, then consumer of the design, the architectural form, aerospace components, then marine design. So advantages: complex, create and free-form shapes easily, highly flexible in design modification, idea for stylizing, aesthetic, for the classier surfaces, requires less system resources than solid modeling, can be converted to solid when needed. Thank you.